Now we can jump into map collidable and, oh, actually before that, sorry. We'll go into CollisionTile and we're going to change things up in here now. So right now, row, call, and tile type are all public. Let's make these private and use our private naming convention to okay, so this now row, call, and tile type are all unused, so let us create a test collision method to use them. So we'll need to include boost optional. So that we can take full advantage of boost optional. So boost optional, it's going to return, like I said, going to go back to it, takes in a side type in a position and returns a units of game representing the point of collision. So boost optional units of game, except I want it to say optional and not optiona. And it's going to be test collision, sides, side type. This is something we're going to need to include. And it's also going to take in a position, so units of game position. So this is going to be a const method actually, so we'll just make it const. I'm going to create a comment, so returns boost none if there was no collision, otherwise the position of the collision on the same axis of side, and side is the side of the tile that is being collided with, and position is the position against the grain on the opposite axis of side. On the tile on the opposite axis of side. How about that? That looks good to me. Now let's go into CollisionTile.cc, create CollisionTile.cc, include CollisionTile, and let's implement this test collision. It's going to be the same logic we've already used before. I could go rip it out of where it is now, but right now it's kind of all scattered around and it's easier to just rewrite it. So we're only going to have a collision, and we're always going to have a collision if our side is equal to, or if our tile type is equal to a wall tile, so tiles, wall tile. And then otherwise it's going to be empty for now, so let's just return boost none in the otherwise case. I'm going to do using namespace sides so that this becomes easier to type. So we're just going to return the position along the side. We're going to ignore position for now because we only need this once we have slopes, but we will use side. So if side is equal to top side, then we want to return the position of the top side. So this is going to be units tile to game row. Otherwise, bottom row +1. And we've done all this logic before. I'm just doing it and centralizing it, and it's easier than copying and pasting, I promise. Left side is call. And then finally, right side is call +1, but we don't, I mean, that's the only other case there is, so it's done. So we have two choices. We could either do Polar Star CC and clean up the CollisionTile stuff in there, or the map collidable. So I'm going to go into Polar Star first, actually, even though you might think I would do the map collidable, but Polar Star happens to be easier. So we'll start with that. So I'm already in here, this polar star projectile update method where we're checking the collision tiles, and then we need to, in here we're calculating the particle x, and then, you know, subtracting an offset and such and such. So we're going to get rid of all this code, almost all of it. So I'll go down to right before we're about to create a particle and just delete all of that code. And then instead of actually checking to see if the tile type is equal to a wall tile, we'll need to check to see if the collision actually occurred. So let's start with that. So const boost optional units of game maybe position, and we'll just initialize it with colliding tiles subi dot test collision, and then we need to pass it in a side as well as a position. So let's figure out the side and the position. The side is going to be const well, the direction is going to be sides, side type direction, and this is going to be equal to sides from facing, and then we've got a horizontal direction as well as a vertical direction. And then we can get our side from this, so const sides, because remember, we don't want to get the side in the same side as the direction, we want to get the opposite side of the direction. So side type side, and that's going to be equal to sides opposite side of direction. Okay, so now we have side figured out. Now let's figure out position. So const, it's going to be units of game, and depending on if we're going vertical or horizontal. So if we're going vertical, let's figure that out first. So position sides vertical. Now you see why I created all these helper methods. So side. So if we're going vertically, then we want to use the x because the x is in the opposite axis. So get x. Otherwise, we want to use get y. And now we have maybe position. So let's check to see if maybe position exists. And that's the same thing as checking to see if there was a collision. So if maybe position exists, there was a collision. And we need to figure out what particle x and particle y are. So units of, we can do const units of game particle x, and that's going to be equal to one of two things. So we need to figure out if we're going vertical. So if we're going vertically, our particle x is figured out for us by position. Otherwise, we need to use maybe position, but we can't just use maybe position. We need to subtract off an offset because that's what we were doing before. We had a minus units, okay, half tile, so that it would show up right in the center of the tile, or centered on the edge of the tile is what I mean. So particle x is figured out. That's easy, easy. So find x. Now let's figure out particle y. So if we are going vertically, then particle y is going to be determined by our maybe position, almost the exact opposite of x. So this is going to again be minus units k half tile, and then otherwise we're going to use our position, which again, if we are not going vertically, is equal to get y. We just have it conveniently stored for us already, so let's use it. The other thing is, I could reduce this a little bit, but I'm not going to. So that is polarStar.cc. So let's jump into map collidable and fix things up there now. So I'm going to start up here in this namespace. We have this get wall collision info. I'm actually not going to call it that because we're not going to be returning collision info anymore. In fact, we don't need this collision info struct anymore. So we can change this to an optional, and I'm going to do using boost optional to make typing a little bit shorter. And we'll just replace all instances of collision info with optional units of game. And then we'll call this get wall collision info. That's not aptly named anymore, so let's just call it test map collision. Now we can get rid of this info because we're not going to be returning an info. Instead, if we get to the end of things and there is no collision, we'll just return boost none. Up here though, we are trying to test for a collision and then returning an info, so instead of doing that, we need to test to see if maybe position exists. So let's do that and figure out what we need from that. So const optional units of game the heck? Const optional units of game, maybe position, and this is going to be initialized with tile sub I dot test collision, and we need a side type, so I'm going to use side for now, and then we'll also need a position, so we'll need to figure out both side and position again. Side is going to come from a direction, so let's take into our test map collision a direction. So find C, find parenthesis. And so let's take in a side type for direction, so we can calculate our side from our direction. So const sides side type direction, or side. This is going to be equal again to the opposite side of direction. So sides, opposite side of direction. Now we need position, and we can get position from the rectangle depending on if our side is vertical or horizontal. So again, I'm going to do some wishful thinking right here. So we're going to do units of game position, and this is going to be equal to if sides sub vertical. So if our side is vertical, then we'll want to use the rectangle center X. Remember, this is from episode 61, center X. Otherwise, we want to use rectangle.center Y, and we actually have to create those methods. So let's go into rectangle.h and create those, and this will be easy, I promise. Center X and find X, center Y. And this X is going to be X plus width divided by 2, and Y is going to be Y plus height divided by 2, and we have implemented those two methods. All right, so now we can use our maybe position instead of checking to see if the tile type is equal to wall tile. So if maybe position exists, then we can just return maybe position. Bam. Make sure I spell this right, maybe position. Whoa, so slow because of recording. There we go. The last thing we need to do is to make sure that all of our test map collision are called with the side. Okay, so there's more than the last thing we need to do. There's actually a few things we need to do. All these infos, no longer aptly named. Let's rename them maybe position. Maybe position.collided, we're just checking to see if there's a collision there, so let's rename those. So let's maybe position, ignore the dot collided, and just lob off the dot collided, so like so. And then finally, we're trying to calculate the position right here, so we'll just change all these units tile to game maybe position. We'll just change those to a quote unquote dereferenced maybe position. So let's find units tile to game maybe position, and then a bunch of characters that are not a closing parenthesis. I don't know how many there are, and then followed by a closing parenthesis, and just replace that with a dereferenced maybe position, and hopefully this works. Oh, I forgot a star, so there's multiple of these not closing parentheses. There we go. So now the only change left is making sure all these test map collisions are passed in a direction too. So I'm going to do this in a macro because there are 8 of them, and yeah, this is incredibly boilerplatey, and we're going to fix this actually in the next episode, get rid of a lot of this boilerplate. But one of the things that's actually necessary to remove this boilerplate was creating a CollisionTile class. So we'll see how we can clean things up in the next episode. So let's create a macro. So I like to start macros the way I finish them, just as I don't know, it makes things easier. You can kind of see, kind of create a loop. And by the way, I'm talking about a Vim macro. So I'm going to start out on optional. I'll start recording a macro. I will I'm going to create a direction, so sides, side, type, and also be careful not to use autocomplete when you're using macros, because it doesn't work when you're doing macros. It probably just doesn't have enough, it's not fast enough. So I'll create a direction, and this is going to be equal to something. I'm going to mark this spot and search for the next instance of sides, and then I'll yank until I find a comma, and then go back to that mark and then paste it in. So now I have direction to make things easier. I'm going to go down, find map, and then I'm going to kind of clean things up here, make sure everything's on visible screen space. So I'll insert direction to the end of our test map collision call. And then I'm going to find the next instance of sides. While I'm here, I'm just going to clean these up and change these to just be direction. And find the next one and change it to be direction. Okay, so now I need to find the next maybe position. And then I'm going to need to create the opposite direction, so another side type for the opposite direction. So const sides, side type, opposite direction, and this is going to be equal to sides, opposite side of direction. And then I'm going to use it inside of our test map. So I will find the parenthesis, find the C, and then go to the end and insert in opposite direction. Then I want to find sides and kind of clean things up again. So sides, change till I find a comma, and then use opposite direction instead of the left side in this case. Now I want to find optional and go back to the beginning, and then hit Q to end the recording. Go to the next optional, and then I will do @Q to run the recording, and it looks like it worked. So yeah, I'll just go through and do it for all of these. @Q to run it again, @Q to run it again. And I mean, sometimes when you're doing recordings, it's nice to have it end on the next place that you need to do it, but when I'm doing a big recording, I like to just end up where I started, just to make sure that I looped it through correctly and it worked. So this looked like it worked out really well. I'm going to save, and Syntastic should tell me if I did anything wrong, horribly wrong, and it looks like I did it right. So now we can build and run and see how it looks. So I'll just go into the terminal for this. So I will make... Wow. So I messed up one of the easier parts, which was rectangle.h. I accidentally said height instead of height underscore. So we'll put that in. You probably didn't make the same mistake. All right, so let's make again. Fingers crossed this works. This was a big refactoring. All right, so let's make run again, fingers crossed. It looks like everything's working out pretty well. Let's test the gun. Oh, okay, good, it worked. So you can make refactorings fast if you just do a bunch of macros like I did, but it can be painful if it doesn't work. So in this case, it worked out just fine. So I'm glad I did it. But yeah, that's it for this episode. Thanks for watching, guys. And in the next episode, we'll clean up this update so we don't have to do all those macro madness and just make our lives easier in general for the future. So thanks for watching, guys, and happy developing.